Hello everyone. Today, we'll be covering basic calculations in Microsoft Excel. If this video seems too fast or slow to you, then you can easily choose the playback speed that suits you. And if you want to watch videos without sound, then just turn on subtitles. I wish you a pleasant viewing. So, the procedure of any calculation in Excel can be divided into 3 stages. Firstly, you need to place an equals sign in the cell where you wish to see the answer. Now, as an example, I'll select cell G6. I'm putting an equals sign. From this moment, the calculator mode in the program is activated, meaning I can now start entering the formula. In this cell, I need to calculate the sum of the numbers 46 and 21. This can be done in several ways. For example, I can simply type these numbers using the keyboard. To get the result, I press the Enter key. Done. In this way, I've gone through the 3 necessary stages. At the first stage, I put an equals sign in the cell. At the second stage, I entered the formula. And at the third stage, I pressed the Enter key to get the calculation result in cell G6. If you want to make changes to the formula, just double-click with the left mouse button on the cell containing the formula. I showed you a way to calculate by manually entering numbers into the formula. However, I can achieve the same effect by adding references to cells where these numbers are indicated. With the backspace key, I'll remove everything except the equals sign. Now, I click on cell E6. As you can see, the reference to the cell was added to the formula, and an animation appeared in the form of a moving border. Next, I put a plus sign and click on cell F6. Both references are added, and all that's left is to press the Enter key. The result is obtained. This calculation method is remarkable in that changing the values in cells E6 and F6 will result in a change in cell G6. Here's how it looks. Moreover, I have a detailed lesson on my channel dedicated to how cells work in Excel. I'll leave a link to it at the end of the video. But for now, let's focus on the main topic of the video. Following the algorithm we've discussed, I'll make calculations in the remaining cells. And the last operation, exponentiation. Here, we use the caret symbol, also commonly referred to as the hat. To enter it, press the Shift plus 6 keys. Done. Now, we've looked at various examples of basic calculations. However, please note that if your table requires the same operations within a single column or row, they can be performed automatically and quite quickly. For example, now in the last column of the table, I need to use only a single operation in the form of adding numbers from columns E and F. In each row, this operation will look the same. Therefore, I enter the formula for adding numbers into cell G6. And now, I simply double-click with the left mouse button on the bottom right corner of this cell. Look, the formula automatically filled in the cells below, and now I won't have to fill them manually. Alright, moving forward. Please note that Excel adheres to the generally accepted order of mathematical operations priority. This means that in a calculation, the operation in parentheses is performed first, then exponentiation, followed by multiplication or division operations, which have equal priority, and finally, addition or subtraction is performed. The last 2 operations are also equal to each other in terms of importance. According to this order, in the first example, the calculation starts with division, followed by multiplication, and only then is addition performed. However, if parentheses are added to the same example, the answer will be different. This is because, in this case, the operation within the parentheses is executed first. Alright, friends, now it's time to talk about functions. A function in Excel is a built-in formula that can be used for various calculations, operations, and data analysis. Take a look at this table. At the end, there is a total row where the sum needs to be calculated. That is, add up all the values from the cells in the last column. If I weren't familiar with Excel functions, I would have had to manually add each cell into the formula separately. This is alright for a small table. Otherwise, I would have spent a considerable amount of time on this procedure. Fortunately, Excel has a special function that handles this much faster. Let me show you how it works. In the total cell, I place an equals sign and type the word SUM. Notice that the program already suggests the appropriate option. I can confirm it with a double click of the left mouse button or by pressing the Tab key. OK. Now, I simply highlight all the cells whose values I need to sum and press the Enter key. Done. Pay attention to the formula. At the beginning, it says SUM, and sum is one of Excel's functions that takes values, processes them in a certain way, and returns a result. In this case, the result is the addition of all the arguments' values. The function's arguments are always within parentheses. In this formula, the argument is presented as a range of cells from the last column of the table, where F5 is the first cell of the range and F10 the last. The colon indicates that the formula specifies a range, not just a reference to a single cell. In my opinion, this is a good solution from the program's developers. It saves us from having to list all the cells from this column with commas because the colon already lets the program know that not only cells F5 and F10 should participate in the operation, but also all cells between them. Furthermore, you can add various arguments to the formula. These could be additional ranges, cell references, or values. Suppose I want to sum data from several ranges. I highlight the first range, then press and hold the Control key, and without releasing it, I select the second range. This time my formula has two arguments. They are a range of cells from column F and from column J. Between them is a special separator, a comma. And here's another example. Let me highlight the range of cells from F5 to F10. Sum it up with the J6 cell and the number 100. I put a comma and add the J6 cell. Again, I specify a comma and type the number 100. Notice that a tooltip appears below the formula, which helps you quickly understand the structure of the function. The first argument is mandatory. Without it, the formula won't work. But as you've probably noticed, the subsequent arguments are enclosed in square brackets. This means they act as additional elements of the formula and their inclusion is optional. Before moving on, let's review the structure of a formula containing a function. This is important because without knowing such basic things, you can easily get confused when dealing with more complex formulas. I've prepared a small diagram for you. So, in our formula, after the equals sign comes the function name, which processes only the data contained within parentheses, specifically those following the function name immediately. If our formula looked like this, the sum function would only process this part of the formula. Accordingly, calculation in this case would proceed in two stages, where the first action is data processing using the sum function, and the second action is multiplying the obtained result by 10. Therefore, despite the commonly accepted definition calling an Excel function a special formula, I'd prefer to call it an element of the formula. As shown in the example, the function is not the formula itself, but just one of its elements. Moreover, a single formula can contain several different functions. But we won't get ahead of ourselves just yet. Got it? Then let's continue. The arguments of the function are contained within parentheses and can vary. In our case, the first argument is a range of cells. You can easily recognize a range by the colon sign between the first cell of the range and the last one. Next, after each argument, a separator in the form of a comma is indicated. This symbol is called the argument separator. Depending on the program's regional settings, the separator can also be a semicolon. Therefore, if adding a comma causes the formula to error, try replacing the argument separator with a semicolon, and then it should work. Well, that clarifies separators. The next argument in our formula is a reference to cell J6. And the final argument is the number 100, which is not tied to any cell and acts as a constant. All these listed arguments represent specific values that are summed together by the sum function. So, you might have some questions by now. For example, where to find other Excel functions and how to use them? In the formula bar, there is a special icon that allows you to find and insert any available function. In the window that opens, you can search for the necessary function by categories, which are divided into financial, logical, mathematical, textual, and so on. Also, to find a specific function, you can use the search bar. I enter the name, press search, and the program shows me the function you were recently introduced to. Just below, there's a brief description of the selected function. And for more detailed information, you can use the help function, as long as you are connected to the internet. In total, Excel boasts more than 400 functions. Of course, we will not go through all of them. First, it would take an enormous amount of time, and secondly, there's no real need, as the main goal is to understand the principle of how functions work. Then, you will be able to independently find functions suitable for solving your tasks and apply them in practice. For this, it is enough to go through a couple of dozen popular functions. Next on our list is a function named count. I type it into the search bar. Good, let's read the description. This function counts the number of cells in a range that contain numbers. Let's try to apply it. I press OK. And a new dialog window opens up. Essentially, it plays the same role as the formula bar, meaning here we can define arguments for our function. The difference is that this window contains tips, and its interface makes inputting arguments simpler and more convenient. For example, I select a range of cells from column E. Notice that the formula bar immediately reflects the changes. But I didn't have to manually write out the formula, as we did a few minutes ago. Moreover, after entering the first argument, the dialog window automatically displays a preliminary result, which equals 6. I press OK. Done. We just applied the count function, which calculated the number of cells in the selected range for us, and thereby we learned that column E contains 6 cells. If I now return to the formula and widen this range by one more cell, the answer will not change because the cell I just added contains text, while this function only counts cells with numbers. If I change one of them to plain text, the count will decrease, and instead of 6, we will get 5. I'll undo the last action to revert to the previous state. Next, Excel has a function that finds the number that occurs most frequently from a selected array. This function is called mode. In this case, I can specify not just a range of numbers, but an entire array. The function analyzed the data from the array and returned a result of the number 50. This means that this particular number occurs more frequently than others in the array we specified. Good. Now let's find the average value in column F. The function we need is called the average value. You're already familiar with the principle of its operation. This function is convenient for calculating the average grade, or for example, the average salary, etc. Similarly, you can find out the maximum or minimum value from a given range. The min function returns the minimum value. But the max function returns the maximum value. Super! Now, I will go to the Formulas tab. Look, here you can also select the needed function, similar to how we did it in the special dialog window. But there's also an interesting tool here named AutoSum. What does it do? Look, I select the last cell in column F and click on AutoSum. The program did all the other work for me, and I only have to press the Enter key, and the sum will be automatically calculated. Okay. In the same way, I can perform other actions, for example, to find out the average, minimum or maximum value, as well as count the total number of cells with numbers as we recently did together, using the count function. This is a convenient solution for simple functions, which will save you time. But, if you want to quickly get the result, and you don't need to enter it into any cell, just select the range you need. And at the bottom of the workspace you will see the same results, such as the sum, count, average value, and so on. This area of the window is called the status bar. By right-clicking on it, you can add other indicators here, just check them, and they will appear. And to finish the lesson, I'll show you a couple more simple, but interesting functions. The first function is called today. Its special feature is that no arguments are required. So the brackets remain empty. As a result, the formula returns the current date to us, and notably, this date will automatically change to the current date every day. You might say it's a small thing, but I assure you, in combination with other functions it can work wonders, and in one of the lessons, you will be able to see this for yourself. And the next function shows both the date and the time. It is called now. The brackets also remain empty. Done. If you press the F9 key, it will recalculate all the formulas in the current workbook, and the time in this cell will be updated. Hello everyone. By watching this video, you will learn how to work with various types of cell references in Microsoft Excel. So, cell references in Excel are divided into relative, mixed, and absolute. Let's start with relative references. In front of you is a table with 4 columns. I need to calculate the sales sum for each product. I place an equal sign in cell E38 and multiply the price by the quantity. To do this, I click on cell C38. Then put a multiplication sign and add cell D38. I press the Enter key. Alright, in the cells below, I need to perform a similar operation. However, I do not necessarily have to do this manually, since I can copy the formula by dragging the bottom right corner of cell E38 to the end of the table. Done. This is how relative references work. For clearer understanding, I will display the formulas. As you see, when copying, the formula maintains its structure. That is, it still performs the multiplication of the price by the quantity. But please note that the cell references shift downwards. This allows us to partially automate our work in Excel. This principle can be applied when copying both vertically and horizontally. I will display the formulas again so that you can once again see the action of relative references on a specific example. Now, let's summarize a bit. Relative references represent a simple and convenient tool when working with tables. Such cell references always shift after copying, while the structure of the formula is preserved. However, there are situations where we need to avoid the shift of references when copying a formula. In this case, absolute references are used. Pay attention to this table. It lists some products, each of which is produced and sold in 3 different configurations. Depending on the configuration, the price of the product will vary. Column C specifies the price of each product sold in the standard configuration. We need to calculate the prices in the remaining 2 columns. Here, the price of the next configuration is formed by adding a 20% markup to the cost of the preceding configuration. That is, to calculate the enhanced configuration, you need to add 20% to the standard one. Accordingly, to calculate the full configuration, the same markup needs to be added, but to the enhanced one. Moreover, we need to ensure that when the markup changes, the prices are automatically recalculated. In other words, the cells must be interconnected. So, I start calculating the price in column D. For this, I need to add 20% to the price in column C. After the equal sign, I open a parenthesis and click on cell C6. I put a multiplication sign and click on cell C1. I close the parenthesis. Then I indicate the plus sign, add cell C6, and press the Enter key. I got the correct result. If you change the markup percentage in cell C1, the price in cell D6 will be automatically adjusted according to the new markup. This is exactly what I need. However, it's too early to celebrate. Look what happens when I copy this formula to the remaining cells. It's immediately evident that a serious mistake was made in the calculations. To understand what's wrong, I enable the display of formulas. Look, for the calculations to be correct, I need to refer to cell C1 in all formulas, where the markup on the price is indicated. In cell D6, the formula calculated everything correctly because I indeed added the markup to the standard price. But upon copying, the formula shifted. For example, in cell E6, instead of referring to the cell with the markup, the program refers to an empty cell with the address D1, and so forth. To solve this problem, it's necessary to make the reference to cell C1 absolute. I will return to the standard display and press the Ctrl+Z combination several times to undo the last actions in the program. Now, I double-click on cell D6. The formula editing mode opened. I position the cursor next to the reference to cell C1 and press the F4 key. $2 signs appeared in the formula, meaning the reference to cell C1 has now become absolute. That is, now when copying the formula, this reference will not shift. It is fixed on cell C1. Let's check how the formula behaves this time after copying. Super, goal achieved. In our formula, there is both a relative and an absolute reference simultaneously. Relative references shift when the formula is copied, but absolute ones stay in place, and thus, in all the formulas of my table, the program refers to the C1 link, which I made absolute. Right now, I want to show you one useful trick. It will help speed up your work in Excel. Holding the left mouse button, I select an empty area of the table where calculations need to be made. The area is selected. Now, I place an equal sign and enter the formula. You already know it, as we have just discussed it. The formula is entered. However, this time to obtain the result, instead of pressing the Enter key, I will press the Ctrl plus Enter combination. Done. The entire selected range immediately filled with the formula, and I didn't have to copy it into the other cells myself. So, take note of this method. We have just discussed absolute and relative references with you. Now it's time to learn about mixed references. We will now create a multiplication table. Its rows and columns contain the multiplicands, and all other cells in the table represent the result of multiplying the corresponding multiplicands intersecting in one cell. For example, to find the product of the numbers 3 and 4, you need to find a cell in the multiplication table where the row with the number 3 and the column with the number 4 intersect. And vice versa. These cells will show the multiplication result, which is 12. And our task is to apply a single formula that will calculate all values in the table after being copied. So, I select the range and enter the formula. I multiply cell B5 by cell C4. Next, I need to ensure that when copying the formula to the adjacent cell D5, the reference shifts from C4 to D4. While the reference to cell B5 must remain static, we don't want it to move to the cell in the neighboring right column. But this is not the only condition. The fact is, we also need to prevent the reference from shifting from cell C4 to C5 when the formula is copied down. However, the shift of the reference from cell B5 to B6 is just what we need, and it must be done. Oh, I hope I managed to explain the task in clear language. If not, you'll understand soon. So, in the formula, I set the cursor next to the reference to cell B5 and press F4. You already know that it is an absolute reference, but in this situation, it won't help us. We need the reference to this cell to be able to shift along the rows while remaining static in relation to the columns. Therefore, I'll press the F4 key several more times. Pay attention, I've prepared a hint to make it easier for you to navigate the reference notations. Now, I've made the reference mixed, here's how it looks, and the hint indicates that with this arrangement of the $sign, we have an absolute column, meaning no shift along the columns, and a relative row. This means we allow movement along the rows. We have now looked at the first variant of a mixed reference. As for the second, it provides the opposite effect, according to which we have a relative column and an absolute row. This exact variant we need to apply to the reference to cell C4. I return to the formula, set the cursor next to the reference to C4, and press the F4 key twice. Do not forget about the hint to correctly place the $sign. And I finish the operation by pressing the Enter combination. The multiplication table is ready. Thank you for your attention. Hello everyone, today you will learn how to make calculations with percentages in Microsoft Excel. I will give you a detailed explanation and demonstrate everything with simple examples. Even a beginner, after watching this lesson, will be able to independently solve problems with percentages. If this video seems too fast or slow to you, then you can easily choose the playback speed that suits you. And if you want to watch videos without sound, then just turn on subtitles. I wish you a pleasant viewing. So, let's start by looking at addition and subtraction. Pay attention to this table. The first column contains numbers, and a little to the right is a column with percentages. Now I will add 15% to the number from cell D5. To do this, I put the equal sign, click on cell D5, put the plus sign and open the bracket. In parentheses, I specify this cell again, and then add a multiplication sign and click on the cell with percentages. Now I close the bracket and press Enter. Done. In fact, I just used the usual mathematical formula. I will calculate the remaining cells in this column by pulling the lower right corner of this cell. Now, in order to subtract percentage from the number, I will use the same formula, only I will replace plus with minus in it. However, there is another way of calculating. Suppose there is no column with percentages in my table, but I need to add 15% to this number. In this case, I can use a simple formula. I add cell D5, put the multiplication sign, open the bracket, add 1. Then, I put a plus sign and indicate 15%. Closing the bracket. The disadvantage of the second method is that when you autofill, the same value will be added to all cells. In my case it is 15%. In general, this option is not always convenient, so I recommend you the first method that allows you to autofill cells with different percentages. So, we have sorted out addition and subtraction. Let's move on to the next example. The table below shows the amount of dividend payments and the tax rate. I need to calculate the amount of tax. I put the equal sign, select cell D22 and multiply it by the value in cell E22. Done. This way I found out the amount of tax that I need to pay. Now we move on to the following table. This time the task will be more interesting. Here is the total amount of sales, and with it I need to find out the share of sales of each employee of the store. In order to do this, I select cell M22. Put a division sign and specify the cell with the final value. Press the Enter key. That is, I divided the sales amount of the first employee by the total amount. Now all I have to do is select the cell with the received answer and in the Home tab, click on the icon with the image of percentages. I did everything correctly. However, an error occurs when I autofill. Everything is simple here. The fact is that if you look at the formulas of the remaining cells of the last column, you will notice that when autofilling in them, the total amount changes to the empty cells located below. But I need to make sure that the cell M30 remains in all formulas, because it is necessary for the correct calculation, and it can be fixed. In order to do this, I will put a $sign before the letter M and after it. And now I will repeat the autocomplete. This time there is no error, and the problem is solved. If I did everything right, when adding all these percentages together I should get the number 100. To make sure, I will perform a check. I click on the last cell and in the tab Formulas, select the command AutoSum. I press the Enter key. As you can see, everything is calculated correctly. It's time to learn how to find the difference between numbers in percentages. Let's take a look at this table. A William Johnson employee sold $132,000 worth of goods in 2021, and sales totaled $158,000 the following year. I need to find out the difference in percentages. I put the equal sign and open the brackets. Next, I add a cell with sales for 2022. Then I write a minus sign and specify a cell with sales for 2021. I close the bracket, put a division sign, and again select the cell with the address X22. Now it remains only to choose the percentage format of the cells. I have already shown how it is done. Good. Everything worked out. Nothing complicated. But what if we need to find the difference between negative numbers? In this case, the previous formula will give an incorrect result. As you can see, the answer turned out to be negative and this is an error. However, it can be easily corrected. To do this, you need to add the ABS function to the formula. Watch carefully what I'm doing now. I specify this function after the division sign, and in parentheses I select the same cell as in the previous formula. This time, the result turned out to be correct, and now you know how to solve problems with percentages in the Excel program. This video will be your assistant, which you can use at any time. Hello, in this lesson we will familiarize ourselves with conditional functions. And I suggest starting with the popular function if. The if function performs a logical comparison of values and the expected result. The first result is returned if the comparison is true, and the second result is returned if the comparison is false. So, you have a table with 4 columns in front of you. The first column contains the names and surnames of the clients, and the second column contains the amounts of their orders. Next, there is an empty column where we need to determine whether the promotion condition is met or not. The result should be entered individually for each client. The essence of the promotion is simple: if the order amount is equal to or greater than $1,500, then the client gets the service package for only $100, otherwise, they will have to pay the full cost of the service, which is $405. I place an equal sign in the third column and enter the if function. The structure of this function is as follows. The first argument represents the condition that needs to be checked. In our case, the condition is whether the order amount, mentioned in cell D7, is greater than or equal to $1,500. Immediately after entering the condition, the function analyzes it and provides the evaluation true, as the order amount of the first client indeed exceeds $1,500, which satisfies the specified condition. For example, if I enter here not 1,500, but 2,000, then the evaluation will change to false. Okay, we understood this. Let's move on to the next arguments. In this field, I need to specify the result that I want to see in the cell if the condition I set is true. Otherwise, that is, if the condition evaluates to false, then another result should be specified. For the second argument, I write the word met. And for the third one, not met. I click OK and get the result. And now I will do autofill. Done. We have just found out which clients met the promotion condition and which did not. Please note that text values in the formula are written in quotation marks. They have been added automatically. However, if you enter arguments through a formula bar, then you need to specify them manually. If you specify text without quotation marks in the function argument, the formula will give an error. Let's move on. Now I will show you an example of using a nested function. I place an equal sign in the fourth column and enter the if function. Let me first fill in the formula completely, and then I will provide my commentary. So, what do we have? I remind you that the first argument of the if function is the condition that needs to be checked and to perform one of the two actions. In our case, using the if function, I task the program to check the content of cell E7, and if it matches the text value in the form of the word met, then Excel should return the result from the second argument, and if it does not match, then from the third one. The second argument is the promotional price for the service package, which is $100. Since this client met the condition of the promotion, they can purchase this set of services for just $100, instead of paying its full cost. Now, the third argument comes into play in the case that the content of cell E7 does not match the specified text value. This time, as an argument, I use the sum function. In this instance, it acts as a nested function, and the value that results from its calculation will serve as the third argument for the if function. So, using the sum function that you are already familiar with, I sum up the values from the second table to find out the total cost of the service package. And to prevent the cell references from this table from shifting down when copying the formula, I made them absolute, hence the dollar signs next to them. We've already covered this, so I won't go into details. Next, I use the fill handle to apply the formula. So, we're done with the table. Of course, this could have been accomplished with a single function, but my goal is to show you different examples of its usage. I've separated the other conditional functions onto a different sheet. They are very similar in their structure, so it's enough to analyze a few of them, which is what we'll do now. Let's start with the SUMIF function. Look at the table. It lists products, manufacturers, and quantities. Now I will calculate the sum of values from the quantity column, but only for a specific product. Let's say this product is milk. I place an equal sign and enter the function name SUMIF. Let's look at the structure. The first two arguments here are mandatory, and the third one is optional, as it is indicated in square brackets. First, you need to specify the range of cells. It can serve both as the area for searching for the product and for summing. In our case, it will be used only for searching for the desired product, and the range from the third column of the table will be used for summing. I select cell C4. And to manually avoid extending the selection to the rest of the cells in the column, I press the Ctrl plus Shift plus down arrow key combination. I insert a delimiter. In the second argument, I specify the item that needs to be found in the given range. And finally, as the third argument, I select cells from the column with quantities, the values of which will be summed, provided that they belong to the selected item. Alright. Thanks to the SUMIF function, we can quickly find out the total number of milk packages sold. The next function called SUMIFs will help us calculate the number of milk packages sold by a specific producer, let's say Dairy Farmers of America. The essence of the function is similar. The difference lies in the fact that here we can specify multiple conditions. So, first I add the range to be summed, then the range to search for the first condition, followed by the condition itself. That is, I'm telling the program to find all cells in the first column of the table with the value milk. After that, I add another range, which will be used to search for the second condition. And then comes the condition itself. Thus, the overall task sounds like this: find all cells with the value milk, produced by Dairy Farmers of America, and sum their total quantity. Now, following the same analogy, we can fill in the remaining tables. Thanks to the COUNTIF and COUNTIFs functions, we can determine the number of cells that contain the desired item, including the desired item from a specific producer. And the AVERIGIF and AVERIGAFs functions will help us find the average value from the overall quantity of cheese sold. The calculation algorithm remains the same as in the previous functions. Done. That concludes our lesson. Hello everyone. We continue to explore Excel functions. And now it's time for VLOOKUP. So, the essence of the VLOOKUP function is that it finds values in one table and transfers them to another. The search principle is quite simple and can be compared to finding the right address in a directory or, for example, dishes from a restaurant menu. Let's say you want to know the price of chocolate lava cake. To do this, you start browsing the menu from top to bottom until you find this cake. Once the task is completed, you stop at that row and shift your attention slightly to the right to find out its price. The VLOOKUP function works on the same principle and is also called vertical lookup. Let's now find out the total order amount and fill in this table, but we won't search for prices ourselves, let the program do it for us. And I enter the VLOOKUP function. The first argument of the function is the value you are looking for. I specify cell C5. I put a comma and move on to the second argument. Here, you need to select the search table. I should note that VLOOKUP looks for the value only in the leftmost column of the table, so if it had one more column to the left, I would have selected not the entire table, but only the part where the column in which the search will be performed is the first column of the table. I make the reference to the specified range absolute, so that it does not shift down when copying the formula to other cells. Well, as the third argument, you need to specify the column from which you want to take the value and pull it into the price cell. In this case, we should specify the column number from the selected range, not the worksheet. Therefore, the first column is considered as number 1, and the second column as number 2. And in our case, we need to specify the second column, as the price is located in it. Next, in the last argument, we are offered to choose the search type. If we specify true or put the number 1, the search for matches will be approximate. But if we choose false or simply put 0, we thereby tell the program that the search for matches should be exact. I specify 0 because I need an exact match now. As for the other option, we will cover it in the same lesson, but a little later. I click OK and do autofill. This way, we saved time and filled in the prices with minimal effort. However, I want to draw your attention to the peculiarity of the VLOOKUP function. The fact is that, looking through the lines from top to bottom, it stops at the closest exact match. This means that if there are several identical values in the list, then the function will select the value that first appears in list. Therefore, use VLOOKUP only in those tables where the column for matching contains cells with different values. Any duplicates may be needed only for certain specific situations. I hope this is clear. Now let's move on. In front of you is a small table that we will fill in now. And a little below is the database. It is from this database that we will pull the necessary values into our table using the VLOOKUP function. Of course, you can fill in the cells one by one. That is, first find the position, then the experience, phone number, and so on. But the problem is that we need to pull data from different columns, so we will have to enter the formula individually for each cell. We cannot simply copy it and get the correct result as we just did in the previous table. However, there is still a solution. Now I will show you how with just one formula, you can fill in all the empty cells of this table. And the array formula will help us with this. I select the range with empty cells, enter an equal sign, and enter the VLOOKUP function. Next, I add the searched value. In our case, it is the first and last name from cell D2. Then I put a comma and select the range of the database table. I put another comma and open a brace. Notice that the bracket is curly. So, as you remember, the third argument of the VLOOKUP function is the column number from which the value will be pulled. In the database table, the column position is the second column of the selected range. Experience is the third, phone is the fourth, gender is the fifth, and city is the sixth. Since we are going to pull the necessary values from all these columns at once, then, of course, in the formula, we need to specify each of them. I list the column numbers, separating them with semicolons, and close the brace. This argument represents an array of constants, and it must be enclosed in curly braces for the Excel program to correctly recognize our command. Now I put a comma and specify 0 as the fourth argument, so that the function performs an exact match search. In fact, we have given the Excel program a command to scan the database from top to bottom and find a person named Stephen Lewis in the leftmost column. In case of an exact match, it will scan that entire row, moving to other columns starting from the second one and ending with the sixth one, and pull the values of their cells into the table located above. All that's left is to complete entering the formula, and for that, I will hold down the Ctrl plus Shift plus Enter key combination. If this is not done, the result will be incorrect. This key combination tells the program that we want to apply an array formula. Hence, the combination Ctrl plus Shift plus Enter in this case is mandatory. You can recognize an array formula by the presence of curly braces. One is at the very beginning of the formula, and the other at the end. They are automatically inserted after pressing this key combination. And in each cell that has been filled, the formula looks absolutely identical. Now, I can select any surname from the database, and all the other information about that employee will be automatically pulled in. By the way, you might be wondering why I listed the columns in curly braces with a semicolon instead of the usual delimiter, the comma. The thing is, a semicolon is used in this case to fill rows. For example, I will now create the same table but transpose it horizontally. I copy the formula into it and press Ctrl plus Shift plus Enter. As a result, all the cells are filled with the same values, which means there is an error in the formula. Since in this table the cells are filled not by rows, but by columns, the array constants need to be listed with a comma. Therefore, I go back to the formula and change all the semicolons to commas. Now I press Ctrl plus Shift plus Enter, and the formula pulls the correct values. I understand that with such a lot of information, things might be getting a little confusing. Don't worry, we will have a separate lesson dedicated to array formulas, where we will go through everything in detail and look at various examples of their use. You might also have a question about how this drop-down list with the employees' surnames appeared. I prepared it in advance. It is quite easy to create, and in one of the lessons, I will show you how it is done. But right now, we need to focus on the subject of the current lesson, and therefore I will move on to the next table. It's time to understand how the VLOOKUP function works when choosing an approximate match. So, on the left, there is a table where you need to fill in the discount column. The discount is determined individually for each customer based on the amount of their order. The table on the right indicates the conditions for granting discounts. For example, if the customer's order amount falls in the range of $11,000 to $15,000, then a discount of 2% will be provided on their next purchase. Accordingly, the first customer will receive 2% and the second one will be left without a discount, as the amount of his order does not meet the minimum conditions and is $10,514, whereas it should have been at least $11,000. Well, as you might have guessed, we will solve this task not manually, but using the VLOOKUP function. First, we need to create an additional column for the match search. Since these cells contain too much data for Excel to handle, we need to simplify the task for it. For this, I will use an additional column, and I will enter only the lower boundary of the search into it. That is, I put 0 in the first cell, 11,000 in the second, and so on. Now is the perfect time to recall Flash Fill. I press Ctrl plus E. And the rest of the data is pulled automatically according to the given pattern. Okay, now I enter the VLOOKUP function. the value to look for will be the order sum. Next, I select the entire range with the promotion conditions including the additional column. It is in this column that the match search will be conducted. That's why I placed it on the left. Because the VLOOKUP function performs the search in the leftmost column. I am specifically repeating certain points several times to make it easier for you to remember them, and yes, I definitely make the reference to the range absolute. So, the next argument of the function is the column number from which to pull the value. Since we are looking for the discount, I specify the column with the discount. In the selected range, this column is number 3. So I enter 3. As for the last argument, this time I choose an approximate match by putting the number 1 or by clicking on the word true twice. Done. Now let me explain to you how the VLOOKUP function works with an approximate match. So, let's consider the first customer as an example. We asked the program to find the number 12,000 in column G. If an exact match had been specified as the last argument, the formula would have given us an error because this number is not present in the specified column. However, an approximate match allows us to solve the task. The program starts searching for the number 12,000 from top to bottom in column G. And as soon as it reaches the value of 16,000, which exceeds our target value, according to the algorithm of the VLOOKUP function, Excel stops at the nearest smaller number, taking a step back to the cell with the value of 11,000 and pulls the value from the third column of that same row, which is 2%. Or, for example, in the case of cell D14, where the order amount is $68,082, Excel also performs a search in column G. Not finding a corresponding value, it stops at the nearest smaller value, which is 36,000 and corresponds to a 20% discount. The task is completed, and the additional column can be deleted. Immediately after deleting it, an error appears in the discount column, which is not surprising since the formula has lost part of the data required for calculation. I intentionally did this to show you the consequences of mishandling data in interrelated cells. But how can we remove this column and still retain the calculation results? I press Ctrl+Z to undo the last action. So, firstly, instead of deleting it, we can hide it. To do this, I move the cursor to the column G letter designation and right-click. From the drop-down menu, I choose the Hide command. Now the extra column is invisible, and the formula is intact. If desired, the hidden column can be displayed again by double-clicking on the border between columns F and H. Additionally, I can change the font color to white, and then the values will become invisible. Great. Well, another option is to copy the cells from the discount column and paste them in the same place, selecting the Values Paste option. Then I simply delete the additional column, without any consequences for the table. Because there are no more formulas in the discount column, only values remain. Therefore, there is no longer any connection. This lesson is coming to an end. Hello everyone. In this short video, I will show you how to use Excel formulas to find out a person's age. You will also learn how to calculate the age difference. If this video seems too fast or slow to you, then you can easily choose the playback speed that suits you. And if you want to watch videos without sound, then just turn on subtitles. I wish you a pleasant viewing. First, you need to enter the date of birth. Please note that by default, the format in this cell is set to General. However, when I enter the date of birth here, the program will automatically change this format. Let's check. Yes, the format has changed. This is very important because soon I will be using the dateDiff function, and if the cell format is incorrect, I will get an error instead of an answer. If the program did not automatically change the cell format to date, you can do it manually. just click on the cell and in the top field, specify the correct format. For more precise settings, right-click and select Format Cells. Here you can choose the desired date format and confirm your choice by clicking OK. In the cells with the answer, you need to specify the numeric format. I immediately select the range of cells and go back to the toolbar. Here I select number. Now let's move on to the calculations. First, we will find out the age of a person in years. I type an equal sign and then write the word dateDiff. Unfortunately, the program does not offer me an option for autofill in this case, but there is no need to worry because the function itself works without any problems. Inside the parentheses, I specify the cell with the date of birth, in my case, it is cell D9. Then I write the word today and leave the parentheses empty. After that, in quotation marks, I write the letter Y. Finally, I close the parentheses. In this way, I instruct Excel to calculate the difference between the date in cell D9 and today's date. And the answer should be provided in a yearly expression, as the letter Y in this formula implies year. I hope you understand the meaning of this formula. I press the Enter key and get the correct answer. If there are multiple dates in the table, you can use autofill and instantly get the result. And to find out the age in months and days, you just need to make a small modification to the formula. For months, we replace Y with M. And accordingly, for days, we use D. If you want to find out the age difference, the formula will look as follows. In my table, I have two dates of birth. In order for the formula to work, the earlier date should be specified as the first argument. Therefore, I select cell X8. And instead of the word today, I specify the second date, which is later than the first one. The rest remains unchanged. Done. If instead of an answer, the program gives you an error, there could be several reasons. Firstly, check the cell formats. Remember that for dates, you should use a format with a similar name. And for cells with answers, a numeric format should be selected. Secondly, check the correctness of the formula. It is possible that you simply forgot to include a parenthesis. Also, the reason could be a peculiarity of your Excel version. For example, there are versions where you need to use a semicolon instead of a comma between arguments. So, try replacing this sign and it might help you. Dear viewers, we are approaching the end of this video. Please like if you enjoyed the lesson and subscribe to the channel if you want to master Microsoft Excel. And in the description and in the first pinned comment, you can find a link to provide financial support to the channel, as all lessons are absolutely free. I wish you success in your learning. Goodbye.